So there's actually one more refinement that we want to make, and that's about error handling. So whenever you're dealing with APIs, whether that's Gemini APIs or other AI APIs or APIs in general, we always need to assume that we can hit errors, whether that's because the service is down at the time, whether that's because we're being rate limited. In case of Gemini, I've often bumped into specific models being unavailable for a while. So for example, when their Gemini 2.5 Flash Lite model was overloaded, I was getting a bunch of errors with my triage step in a previous pipeline that I've built. We actually didn't encounter anything like this yet for the pipeline that we've built together, but that doesn't mean that these things won't happen. So as part of being good agentic engineers, I think it'll be important for us to anticipate this and make sure we have at least some rudimentary error handling in place, especially for our LLM APIs, where this tends to be more likely. So for example, here we are looking at the synthesis step, right? You see that here we instantiate our agent, and then down here in the process function, we just call agent.run. Then we just assume that the call is successful, and we proceed to processing the result. So this is one example where we would expect to have some exception handling, so we can deal with errors that come up and then handle them elegantly. The best thing we can do for now is to have some basic retry logic. So if it fails the first time, we should just try it again a couple more times, ideally with a exponential backoff, right? So that means initially we'll just wait maybe a few seconds, then we'll wait, twice that long, and so on. We'll double that a few times. And that way, if the API briefly has some downtime, chances are that we'll be able to gracefully recover from that, and the pipeline will still be successful. It's even more important for the batch steps, right? So here we have the batch step class that's extended by both the triage and extraction steps. But overall, the structure is pretty much the same. So here we just deal with the parts that are general to all of those steps. Down here in the run batch function is where we call agent.run. So there's no exception handling or anything like that here either. So let's write a prompt for Claude Code to improve this. Okay, so let's try this prompt. This is inspired by the error handling that I'm using in my production pipeline. So hopefully we can make this one just as robust. So I'm saying we currently don't do any exception handling for our Pydantic AI calls to the Gemini API. In practice, API errors are quite likely due to temporary model unavailability, rate limits, and other issues. Please implement retry handling for AI agent calls. Requirements. Okay, so now I'm listing the retryable errors. So in our case, those are timeouts. So sometimes this just happens where an agent will hang, and we're going to implement a timeout where we automatically kill this after a certain number of minutes and then retry again. And then we also have a bunch of errors in the HTTP 500 range. So oftentimes it's literally 500 when a model is unavailable. So those are retryable. And then also HTTP 429, which it returns for rate limiting. And then all other errors should raise immediately. So it is quite important to distinguish between the different types of errors that we're getting back, because retrying other classes of errors usually won't do us any good. Then we have our retry policy. So we're going to retry each error 4 times, or up to 4 times, so 5 total attempts. We'll use an exponential backoff. So the base delay is 5 seconds, and then we'll double this at each attempt. So 5, 10, 20, 40, 80, and then 120 is going to be the highest that we use. Technically, we won't reach this because we only have 5 retries, but this should all be controlled with constants, and we could end up deciding to retry more often. We probably don't want to wait more than 2 minutes in between retries. And then here, we're also instructing Claude to add a plus or minus 25% random jitter to each delay to avoid a thundering herd, right? So that's when maybe the model is temporarily unavailable. We're processing 5 batches in parallel. All of them will get this error. They'll all wait, say, exactly 10 seconds, and then all hit it at exactly the same time. That's not great either, so introducing a jitter means that we spread them out a little bit. For timeouts, we're going to use a 5-minute timeout per attempt. In practice, this should be very, very rare. I've only bumped into this a few times, but it can happen, so it's better to have some handling for this in place. And then for batch processing specifically, we also state, if a batch fails after exhausting all retries, raise a runtime error to abort the pipeline. The pipeline is state-based. Items are tracked as pending in the database, so aborting on failure is safe. A resumed run will reprocess only the items that didn't complete. Okay, so let's kick this off. Let's add plan mode. Okay, here is Claude's plan. The pipeline makes Gemini API calls via Pydantic AI with no retry logic or timeouts. Transient failures, rate limits, 5xx errors, timeouts cause the entire pipeline run to fail. Since the pipeline is state-based, items tracked as pending in DB, it's safe to raise runtime error on exhausted retries. A resumed run will reprocess only incomplete items. Alright, so it's proposing to add a new retry module with is retryable. Okay, this will basically determine based on the exception whether this is considered retryable or not. I like that. We're kind of encapsulating this cleanly in one place, so we can change it if needed without having to touch all the places where we use this. And then we have this run with retry function. So using kind of a coroutine pattern here. That seems like a pretty nice way to solve this also. Then we have the async io.wait4, where we implement the timeout. 5 attempts, exponential backoff, the jitter, we'll log each retry, and then raise runtime error after all attempts are exhausted. Yep, that seems perfect. Okay, we'll add this to the pipeline step. Cool. Update the non-batch step process methods. Yep, looks good. Notes. Okay, that's just new libraries. Okay. No tests needed. Retry logic itself is tested via manual pipeline runs. The deterministic helper is retryable, could be unit tested, but is trivial enough. Well, that one is trivial, I agree. I do think it might be nice to have a test here. I don't know. I mean, in general, we try not to test the libraries themselves that we depend on. Let's add a comment here and challenge it just a little bit to see if maybe it can think of a way to add a test that's valuable. Okay, so the comment I added is, please reconsider this. I do think testing the retry logic might be useful. Because this doesn't happen much in practice, it's difficult to confidently test this behavior during regular pipeline runs. Perhaps we can make an exception to our usual testing conventions here and mock the Pydantic AI API to simulate an error. So let's do this. See what its response is. Good point. The retry logic is deterministic and worth unit testing. We can test run with retry and is retryable directly without touching Pydantic AI at all by passing in a simple async callable that raises controlled exceptions. Let me update the plan. Perfect, that's even better. Okay, now it has a whole testing section. No Pydantic AI mocking needed. Great. And then some test cases. Succeeds immediately, fails with non-retryable error. Okay, great. Let's build this. Okay, it finished. So we have the retry module, changes to base Py, ideation, production, and tests, 11 tests. Sounds promising. Let's take a look here. Let's start with the retry file. Okay, so I like that it added constants for everything. So the timeout, 5 minutes, number of retries, the base delay, the max delay, the jitter factor. Here's the function for figuring out if an error is retryable. So it's just 429 and anything in the 500 range. And then here's the new function for running something with retry. Yeah, I really like this implementation. It's not specific to Pydantic AI or anything. We can just pass a function in here, and then basically it'll automatically benefit from this retry logic. There's some logging. Okay, perfect. Let's look at the base. So here's our pipeline step. We have a new call agent function that runs the agent with retry. Simple enough. And then we use this down here in the batch step. So when we run the batch, before it was just agent.run, now we're doing call agent. So that's a simple change, and I'm guessing the changes in ideation and production will be equally simple. So it's just swapping out agent.run with this call agent function. Same here. And this should be the same for the writer step, visualizer step, and the image generator step. Nice and simple. All looks well encapsulated. Let's look at the tests. Okay, so that's just testing whether these exceptions are retryable the way we expect them to be. Here's testing the actual run with retry function. So we're passing in these different mocks. Yeah, I like that. Nice and simple. So let's run the tests. Okay, everything passes. And let's run the pipeline once. Okay, it finished successfully. So I'm going to commit these changes. All right, so now our pipeline should be nice and robust if we encounter these sorts of errors.